Hey everyone, welcome back to Fitness Coder. So today we are looking at a new problem. It's called binary search. In this problem, they have given us one array and they have asked whether this target is present in that array or not. If it is present, then return its index. Otherwise, return -1. So here in example 1, you can see array is given and target is given. So as we can see, 9 is present at index 4, hence output is 4. In example 2, target is 2. 2 is not present anywhere in the array, hence output is -1. Also, one more condition, they have asked us in big O of log n time complexity. We'll see that later. So first of all, let's take this example into a separate window and we'll think about a brute force approach. So this video will be divided into two parts. First one will be the approach to solve this problem and later we'll code it. So now brute force approach, what we could think of, we could take this target and we'll keep on comparing it with each element of this array. Meaning for loop, we'll compare 9 with -1, then 0, then 3, then 5. Here we would find our 9 and we'll return 4. So it was clearly a for loop, but in this scenario, we'll end up our time complexity of big O of n, which is a linear search. But they have asked us in big O of log n, which is binary search, right? So binary search only gets applied on monotonic functions, meaning functions or arrays which are sorted in ascending or descending order. Here we can see this array is sorted in ascending order. As you can see, -1, 0, 3, 5, all are in ascending. And we can apply binary search here. So to apply binary search, we need two pointers. First one is start, that one is end. Start will be at 0th and end will be at last index of the array. We'll calculate mid from it. So to calculate mid, we'll write like this: mid equal to start plus end by 2. Here from pick, we can say 0 plus 5 by 2 and mid will be 2. So our mid will be like 2. We'll check whether this element at mid is equal to our target or not. It is not equal to our target clearly. It is less than our target. In that case, we'll shift this start to mid plus 1, a next position, because we are sure that this mid was less than target. So before this element, there will be no element that will satisfy our condition to reach out to our target. Hence, we have shifted this start to mid plus 1. So start will come here. Again, we'll calculate mid, which will be like 3 plus 5, which will be 8 by 2, which will be 4. So at 4, 9 is present, which is equal to our target, and will return 4 in answer. Sometimes it might happen that two conditions we need to follow, like that we have seen here, that at second position, when once we calculated mid at start, we couldn't find our target, right? It was less than our target. So in that case, we have taken one step, which is like, if our calculated mid was less than target, at that time we'll move our start to mid plus 1, right? And one more thing, vice versa of this, if our mid is greater than the target, so in that scenario we'll take end a step before than mid. Yeah, and sometimes it also happens that we couldn't find our answer in this array. In that case, we'll return -1. So yeah, this was the approach to solve this. So let's try coding it and we'll see how it goes. Okay, here, let me remove it. Yeah, sure. So first step, take a start pointer at 0, as we have seen here, like this, and end at the end of index of array, and will be like end of index. And from here we have to calculate mid. For arrangement, I have written like this. So why I made this arrangement? Because we know that integer lies from minus 2 raised to 31 to 2 raised to 31 minus 1. This is the range of integer. Sometimes it could happen that start is pointing at 2 raised to 31 minus 1, and end will be also at 2 raised to 31 minus 1. So in that scenario, if we could calculate mid, which will like start plus end by 2, in that case it would go out of range, of an integer. So for that purpose I made this arrangement and written like this. So next step, like we were calculating this mid every time, but how long we need to calculate it, right? We need to stop somewhere. So it should stop at a point where start or continue till start is less than equal to end. If start becomes greater than equal to end, then it should break. So we'll put that condition in a while loop. Here we need to check first our calculated mid is equal to our target. If it is, return mid, else our second condition like this: if nums of mid is less than target. So writing it again, nums of mid is less than target. If it is so, what we have done, we have taken start a 1 plus ahead than a mid. So start will be like mid plus 1, and else if that is also not possible, then we have to take end one step before. Yeah. And once we have readjusted start and end, we have to recalculate the mid. And there might be a case where we might not end up with our answer. In that scenario, we have to return -1. So returning -1. Yeah, let's try running it and see how it goes. Okay, error. Let me check it again. Yeah, sure. Okay, working fine for this case. Let's try another case. So we are searching for an element which is not present in the array. Expecting -1. Yeah, let's try submitting it. Yeah, so it was 0 millisecond. It's good. And one more thing, like they have asked big of log n. So how it goes to big of log n time complexity, right? So that is the question. Here we are taking, like for first, our array size was n. Later we were searching in either left or right side of the array. So the array size become means after calculating mid. So it becomes n by 2. Here also, if we couldn't find our answer, then later also we are calculating mid and checking in that portion. So again, half of n by 2 becomes n by 4. So this is going half of every time. Meaning, if we try writing it like this way, at start it was n, later it became n by 2, later it became n by 4. Again, for next iteration, it became n by 8. So this is keep on going in the range of n by 2 raised to power. We can write it like this way: n by 2 raised to k. And this n by 2 raised to k will come when array size will be 1. N by 2 raised to k. By recorrecting it, we can see n equal to 2 raised to k, and which will simply gives us k equal to log n. So this is how we end up at big of log n. So this was all about for a binary search. Thanks for watching. Thank you.